What happens when the sun itself takes a swing at a visitor from beyond the stars? Just as Earth reeled from record breaking solar storms and volcanoes roared to life across the Pacific Rim, a coronal mass ejection, one of the most violent outbursts our star can unleash, slammed straight into 3I Atlas, the interstellar object that has already defied every expectation. By all accounts, the impact should have shredded it into a debris cloud, but the glowing green traveler emerged intact. Or did it? Some astronomers whisper of a sudden brightening, others of fragments drifting like shadows in its wake. Could the sun's fury have altered its trajectory, or even triggered a transformation we weren't meant to witness? Tonight, we peel back the veil on this cosmic collision and ask, are we seeing coincidence or a pattern written into the universe itself? Stay with me until the end. What you'll hear may change everything. The solar storm that shouldn't have spared it. When the sun unleashes a coronal mass ejection, the scale is almost impossible to comprehend. 1 billion tons of charged plasma erupt outward, traveling millions of miles an hour, and anything caught in its path is bathed in radiation and particle flux strong enough to short-circuit entire power grids on Earth. The Carrington event of 1859 set telegraph lines ablaze. A similar event today could take down satellites, fry electronics, and plunge cities into darkness. Yet in late September, one of these storms left its mark not on Earth, but on something far stranger. An object drifting into our solar system from the stars. Designated 3I Atlas, it was expected to be nothing more than a fragile body of dust and ice, perhaps a faintly glowing speck. When the CME struck directly, scientists quietly prepared for the possibility that it might disintegrate. But it didn't. Instead of vanishing into a cloud of dust, the object emerged brighter, sharper, and somehow intact. The normal physics of comets suggested a different outcome. A fragile nucleus, battered by an eruption on the scale of a solar hurricane, should fragment instantly. Yet telescopes recorded a survivor. The fact that an interstellar traveler could withstand such punishment raises questions that conventional explanations struggle to answer. Did its composition include exotic metals? Was it shielded by some natural but unusual crust? Or is there something about these objects from deep space that we still don't understand at all? The shock was amplified by the timing. Just days earlier, Earth had experienced its own geomagnetic unrest as the same solar cycle unleashed storms across the upper atmosphere. Auroras stretched farther south than usual, dancing in skies over cities unaccustomed to them. Pilots reported disruptions in navigation systems. Satellites flickered and rebooted. And then, at the very peak of solar chaos, the sun directed a furious blast into the void, aimed squarely at the path of 3 Atlas. It was almost as if our star itself had chosen to test the endurance of this visitor. In the aftermath, astronomers scrambled to interpret what they saw. Reports from observatories spoke of a sudden increase in brightness, the kind that could indicate fresh material exposed from beneath a crust or fragments scattering light differently. But no clear debris field was detected. Instead, a persistent glow lingered, green and spectral, reminding many of the peculiar hue that had already set Atlas apart from other comets. Theories began to fracture. Some argued that the CME simply peeled away layers of volatile ice, causing an outburst that mimicked survival. Others countered that the lack of dispersion implied resilience, not fragility. The mystery deepened when early orbital data suggested that something had shifted. Not much, just enough to catch the attention of those who track objects on hyperbolic paths. A coronal mass ejection carries immense energy, but the force it exerts on a body as massive as a comet is typically negligible. Yet, if Atlas's trajectory has been nudged even slightly, it suggests that interaction with the storm was far more complex than textbooks describe. Plasma streams could have penetrated cavities within it, creating localized explosions that functioned like thrusters. Or perhaps magnetic coupling altered its course in ways we've never measured before. This possibility unsettled researchers. Interstellar objects like Oumuamua and Borisov had already rewritten parts of astronomy's rulebook. Oumuamua accelerated in strange ways without the visible coma of gas jets. Borisov looked more like a normal comet but still carried a signature of alien chemistry. Atlas was expected to follow predictable lines until the sun itself decided to intervene. The fact that it endured a direct hit without shattering makes it an anomaly among anomalies. Questions mounted. If it wasn't destroyed, did it split? Some images hinted at faint clumps trailing behind, as though shadows detached from the core. Were these fragments real or artifacts of observation? If they were real, then Atlas is no longer a single traveler, but potentially a swarm, each fragment carrying the same unknown properties that allowed the parent body to withstand solar wrath. That scenario changes the stakes entirely. One body can be tracked, its orbit calculated with precision. A swarm is chaos, a rolling dice across the planetary system. Comparisons to Oumuamua became unavoidable. That elongated, tumbling shard baffled scientists in 2017 with its odd acceleration and lack of expected tail. At the time, some speculated about artificial origin, a solar sail, a probe, or engineered debris. Those theories were dismissed by many, yet they linger in the background. Now, with Atlas defying destruction under conditions that should have been lethal, echoes of those debates return. What if these interstellar wanderers are not simply random chunks of rock and ice? What if they represent something else entirely, natural or not, that interacts with stars in ways we barely understand? The raw energy involved is staggering. A CME carries energy equivalent to billions of nuclear explosions. Earthly matter, satellites, spacecraft, even atmospheric layers quails before such force. And yet Atlas survived. One explanation suggests density, a metallic or magnetic heart that could redirect the plasma's violence. If so, this would imply a structure far heavier and more compact than the fluffy, fragile comets we know. Another possibility is geometry, an unusual shape that allowed plasma to flow around it, sparing the nucleus from complete destruction. Either option rewrites assumptions about how matter can form and endure in interstellar space. Even stranger is the color. Before the strike, Atlas's glow had puzzled observers. Green, but without the usual cyanogen compounds that give comets their hue. After the CME, the glow intensified rather than diminished. Some suspect exotic chemistry. Others whisper about processes that mimic technology, like energy absorption and re-emission. Speculation veers into uncomfortable territory, but the fact remains, the glow doesn't add up. Meanwhile, on Earth, the week of the strike saw natural disasters unfurl with uncanny timing. Seismic unrest along fault lines, volcanic activity spiking in the Pacific. Scientists insist these are unrelated, products of tectonics and chance. But for those attuned to patterns, the alignment of solar chaos, terrestrial upheaval, and the survival of an interstellar object feels like a script too strange to ignore. And then comes the silence. Beyond scattered reports, there has been little mainstream coverage. Astronomical institutions note the event in technical bulletins, but without emphasis. The wider public remains unaware that a visitor from the stars just endured the wrath of the sun and emerged glowing. Some argue this restraint avoids panic or wild speculation. Others wonder if the absence of coverage is deliberate, a decision to keep the mystery contained until more is known. Yet those who watch closely understand that something extraordinary has occurred. The sun tested an interstellar traveler, and the traveler survived. What that means for science, for our understanding of cosmic resilience, or for the possibility of deeper mysteries behind these visitors, is still unclear. But the first chapter has been written in plasma and light, and its implications may haunt astronomy for years to come. Timing too perfect to ignore. Sometimes it isn't the event itself that unsettles scientists and skywatchers, it's the timing. In astronomy, random coincidences happen all the time. Stars flare, planets align, and comets appear without regard to human calendars. Yet when a chain of unrelated events unfolds within the same narrow window, the human mind refuses to dismiss it as chance. That is precisely what happened when 3 Atlas endured a direct solar strike. The days leading up to the impact were already unusual. The sun, entering one of its most active phases in the solar cycle, had unleashed several medium-strength storms that lit up Earth's skies with auroras far beyond the Arctic. People in Germany, France, and even northern US states reported shimmering veils of green and purple light dancing overhead. For many, it was beautiful. For those who track the sun's moods, it was a warning. The peak of solar activity is not expected for another year or two, yet the eruptions arriving early suggested a cycle moving faster, hotter, and perhaps more violent than predicted. It was during this period of heightened energy that a coronal mass ejection launched itself into the void. At first, astronomers assumed its trajectory would graze near Earth's magnetic field. Models projected minor geomagnetic disruption, nothing catastrophic. But as calculations refined, something startling became clear. The CME wasn't aimed at Earth at all. Instead, it lined up almost perfectly with the projected position of 3I Atlas, the interstellar wanderer slicing through the inner solar system on its one and only pass. Think about that. A billion-ton plasma cloud traveling millions of miles, intersecting the path of an object that itself had arrived from another star system, all within the same week Earth was lighting up from solar storms. The odds of such precise overlap are astronomical in the literal sense. Some observers likened it to two needles thrown into a haystack and colliding midair. Yet it happened, and it happened when public attention was already focused on auroras, solar warnings, and signs of unusual celestial behavior. The timing did not stop there. On Earth, tectonic restlessness seemed to mirror the sky. Within days of the CME's release, earthquakes rattled South America and volcanic activity spiked in the Pacific Ring of Fire. Statistically, such geological events have no causal link to solar storms. The heat and plasma of the sun do not reach Earth's core in any direct way. Yet history is littered with accounts of strange correlations. Massive quakes striking days after unusual auroral displays, volcanic eruptions coinciding with heightened solar output. Scientists remain cautious, calling them coincidences. But for those watching the sky in September, the pattern was unsettling. It is one thing for the sun to lash out, it is another for its fury to intersect with an interstellar traveler at the exact moment Earth itself seemed restless. The sense that something larger is in play began to echo in forums, observatory discussions, even quiet academic debates. Was this simply the clustering of random events, or are there deeper rhythms that connect the heavens and the Earth in ways we have not yet mapped? Adding to the mystery was the historical context. Just months earlier, astronomers had flagged Atlas as a comet of unusual brightness relative to its size. Its green glow had already sparked theories of exotic chemistry. By the time the CME collided with it, observers were primed to expect the unexpected. When the object survived intact, glowing even brighter, the sense of timing sharpened. The sun had tested it, and the universe had staged the trial during one of Earth's most charged weeks of solar interaction in years. The media, curiously, had little to say. News outlets ran stories on the auroras and the solar storms. They highlighted disruptions to airlines, satellites, and communication systems. But few mentioned that an interstellar visitor had been directly struck by the same forces wreaking havoc closer to home. It was as if the two stories, the Earthside auroras and the survival of Atlas, were kept separate, compartmentalized, never presented as a pattern. Only those piecing together both sides of the timeline noticed how synchronized it truly was. The coincidences stack further when we consider astronomical context. This was not the only significant event in the skies that season. Two novas, stellar explosions bright enough to be seen with the naked eye, had also flared in neighboring constellations earlier in the year. For the casual observer, that detail may feel distant, but to astronomers, the clustering of rare stellar and solar phenomena within a single calendar year raises eyebrows. We expect scattered randomness, not alignments of the extraordinary. Yet 2025 has delivered multiple cosmic surprises in rapid succession. Skeptics argue this is nothing more than the law of large numbers. With billions of stars and countless potential events, some of them will cluster by sheer chance. But the human instinct for pattern recognition does not surrender easily. We are wired to connect dots, to search for meaning in the noise. And when those dots involve interstellar travelers, earth-shaking quakes, and solar storms timed to near perfection, even the rational mind hesitates before dismissing it all as coincidence. Scientists who speak candidly admit that the CME's precise overlap with Atlas was statistically unlikely. They acknowledge that the survival of the object only sharpens the anomaly. Yet most remain cautious, unwilling to feed speculation about cosmic design or hidden forces. The official line remains firm. The timing is remarkable but explainable. The survival curious but not impossible. Unofficially, the conversations are more hesitant. Astronomers know the history of Oumuamua, the debates it sparked, the reputational risks that came with suggesting artificial or exotic explanations. They tread carefully, even as their private notes betray the strangeness of the event. For the public, however, the mystery is irresistible. The alignment of auroras, quakes, solar storms, and the survival of a glowing green comet from another star reads like something from myth. Ancient cultures would not have hesitated to link them. They would have seen omens in the sky, warnings written in fire and light. Today, we cloak those instincts in science, but the unease lingers. The timing is too clean, too synchronized, to dismiss without a second thought. One could argue that the timing itself is the story. Not the CME, not the survival, not the auroras, but the way they all overlapped within a narrow window of days. The universe may not care about narrative, but humans do. And when events unfold in ways that look scripted, we feel compelled to search for the author, even if it is only the blind mechanics of cosmic cycles. If the timing is not coincidence, then what? Some speculate about larger solar system patterns, gravitational alignments subtly influencing both Earth's geology and the sun's behavior. Others whisper about interstellar visitors triggering responses in ways we cannot yet detect, as if their arrival interacts with our star directly. More cautious voices suggest unknown feedback loops between solar magnetism and planetary tectonics. None of these theories are proven. All of them reveal the discomfort scientists feel when timing aligns too perfectly to ignore. The survival of Atlas after the strike would have been noteworthy on its own. But set against the backdrop of Earth's auroras, solar storms, and seismic echoes, it becomes something more: a signpost, a puzzle, a riddle written across the heavens. Whether we call it coincidence or connection, the fact remains, the timing could not have been more unnerving. And yet, as extraordinary as this overlap seemed, it was only the beginning. The story of Atlas did not end with survival. It continued with a series of observations that suggested the object was not just enduring, but transforming. Its brightness, its glow, even its orbit began to shift in ways that defied simple explanations. The perfect timing of the solar storm was merely the prologue to a deeper mystery waiting to unfold. The green survivor, brightness anomalies. When astronomers pointed their instruments back toward 3I Atlas after the coronal mass ejection, they expected to see a smudge, if anything at all. A cometary body struck head-on by one of the sun's most violent outbursts should have been stripped bare or shattered outright. The scientific models predicted a rapid dispersal into dust, the nucleus lost in a haze of debris that would slowly dissipate. But instead, the opposite happened. The faint wanderer flared into view, glowing brighter than it had since discovery, and doing so in a color that puzzled experts, an eerie, almost unnatural green. Brightness in comets is usually straightforward. As they approach the sun, ice sublimates, jets erupt, and the surrounding coma reflects sunlight. The result is a gentle brightening curve, peaking near perihelion and fading afterward. But Atlas did not follow this arc. Its luminosity spiked almost overnight, not with the typical bluish or white glare of water ice, but with a saturated emerald hue that cameras and telescopes captured unmistakably. The anomaly wasn't subtle. It was glaring, as though the object had absorbed the sun's fury and now radiated it back in colors that didn't belong. For those who monitor chemical signatures, the puzzle deepened. The green coloration of most comets comes from diatomic carbon, a short-lived molecule that glows under solar ultraviolet light. But spectroscopic checks suggested that Atlas lacked the expected levels of this compound. Its coma did not match the fingerprints of cyanogen or C2 emissions typically seen in bright green comets. What then was responsible for the display? Was the CME powerful enough to trigger reactions that generated exotic compounds, or did it simply expose materials buried deep inside an interstellar object that had never been illuminated before? Scientists are cautious when discussing anomalies. They know the danger of overstating, of turning natural quirks into sensational stories. But some admitted privately that the brightness pattern looked less like a comet's natural response and more like a flare. A sudden, unnatural release of energy that surged and then steadied into a new baseline glow. The words energetic release and excitation event began appearing in technical notes, euphemisms for something that couldn't be explained by the usual outgassing narrative. The anomaly also raised questions about structure. Was Atlas coated in a crust that acted as a shell, holding volatile compounds in until the CME cracked it open? If so, The timing of the flare makes sense. The solar blast would have pierced the outer layer, venting gases in a violent release. But that still didn't account for the persistence of the glow. Normally, such an outburst fades quickly as material disperses. Instead, Atlas maintained its heightened brightness for days, then weeks, as though the CME had awakened something that continued to burn. Telescopic images from multiple observatories confirmed it wasn't a trick of atmosphere or equipment. The glow was real, the hue undeniable. Amateur astronomers even reported visible differences through backyard scopes, something rarely possible at such distances. The interstellar traveler had become not just a survivor, but a spectacle, a glowing green enigma in the night sky. Historical echoes only sharpened the sense of mystery. Oumuamua, the first interstellar visitor, had also exhibited brightness anomalies, though in different ways. It reflected sunlight erratically, tumbling like a shard of metal and accelerating slightly as if propelled by unseen forces. Atlas's anomalies were different, steady, spectral, almost as if it had been charged by the sun and now radiated like a neon beacon. Together, they formed a pattern. Every confirmed interstellar object behaves in ways comets shouldn't. Theories multiplied. Some suggested the green glow was the result of ionized oxygen, an element rarely abundant in cometary comas, but possible if Atlas carried frozen water and exotic compounds from its star system of origin. Others proposed that solar radiation had triggered unusual plasma interactions, essentially turning the comet into a short-lived magnetosphere of its own. Plasma physics at such scales is poorly understood. Perhaps Atlas was teaching us lessons we hadn't realized we needed to learn. Speculation inevitably drifted further. Could the brightness be more than chemistry? Could it represent an engineered resilience, something designed to harness solar storms instead of crumbling under them? Such ideas were whispered at the edges of forums and late-night astronomy podcasts. Mainstream scientists dismissed them, but the whispers persisted. After all, the object had survived a direct solar strike, brightened in a way natural comets rarely do, and radiated a hue without a conventional source. The temptation to think beyond natural explanations was strong. Even within the cautious framework of astrophysics, one fact was clear: the numbers didn't add up. The CME that hit Atlas carried energy comparable to billions of nuclear detonations. Any comet of ordinary composition should have fractured instantly. The survival and brightening implied not just resilience, but interaction, an exchange between solar plasma and cometary matter that went beyond simple heating. Some astronomers proposed that Atlas might contain materials with unusually high albedo, bouncing radiation back rather than absorbing it. Others suggested superconductive properties at extreme temperatures, an idea that straddles the line between speculative physics and science fiction. Observers noted another curious detail. The flare of brightness did not correspond with a proportional increase in dust. Normally, when comets brighten suddenly, the coma expands with visible particulate matter. But Atlas's coma looked cleaner than expected, its brightness more luminous than particulate. It glowed like a gas discharge lamp, not like a dusty ball of sublimating ice. That distinction may sound subtle, but in comet science it is critical. Dust leaves trails, spreads, and dims unevenly. Gas excitation glows evenly, smoothly, and unnaturally bright. Atlas leaned heavily toward the latter. All of this fed into a growing unease about timing once again. The flare occurred immediately after the CME, during a week when Earth itself was drenched in solar storm activity. If Atlas had simply brightened at random, it could be dismissed, but tied directly to the sun's most violent outburst of the year, it began to look less like coincidence and more like consequence. The sun struck, the traveler glowed, and the universe watched. The anomaly sparked questions about trajectory as well. Brightness changes affect how light curve data is interpreted. If Atlas's glow came from sources other than reflected sunlight, its apparent size and density might be miscalculated. That could distort models of its orbit, suggesting deviations that were either real or artifacts. In either case, uncertainty grew. Was Atlas still on the same hyperbolic escape path, or had the CME altered it subtly? The green glow, in this sense, was more than cosmetic. It might conceal shifts in momentum that astronomers would only realize months later. Speculation also reached into cultural memory. Ancient civilizations often recorded glowing green stars or visitors in their chronicles. Could they have witnessed similar interstellar pass-bys, objects that survived the sun's wrath and shone with the same uncanny hue? Legends of starstones and emerald fires are scattered across mythologies from Mesoamerica to Mesopotamia. These parallels are tenuous but tantalizing. If humanity has seen such objects before, perhaps our stories have preserved fragments of truth. The brightness anomaly remains unsolved. Scientists log data, refine models, and propose cautious hypotheses. But none fully explain why Atlas glows the way it does, or why the glow intensified instead of fading after a solar impact. The words, "we don't know yet," appear often in the reports. For an object crossing our skies only once, on a trajectory that ensures we will never see it again, the clock is ticking. Every night it glows, and every night the mystery grows deeper. For those who track it obsessively, Atlas is not just a comet anymore. It is a survivor, a beacon, a riddle that radiates in colors beyond expectation. And while the glow fascinates, it also unnerves, because in the cold void between stars, survival under fire is not the rule, it is the exception. Atlas should have perished. Instead, it shines brighter than ever, daring us to explain how. And yet, as compelling as the brightness anomaly is, it is only one thread in a larger tapestry. The green glow points to secrets in its chemistry and resilience, but the questions of orbit and trajectory remain. If the CME altered its path, even slightly, the consequences could ripple far beyond the glow we see today. What came next was not just a mystery of color, but of motion, of direction, of where the interstellar traveler might now be heading. Trajectory questions emerge. For astronomers, numbers are everything. Position, speed, angle, and time can turn the incomprehensible vastness of the cosmos into a predictable dance. When a comet or asteroid is discovered, the first priority is calculating its orbit. With enough observations, its trajectory can be pinned down with exquisite accuracy, predicting where it will be years, decades, or even centuries into the future. That precision is one of science's proudest achievements. But when 3 Atlas endured a direct strike from a coronal mass ejection and then flared with its eerie green glow, the calculations stopped adding up as neatly as they should have. At first, the numbers looked reassuring. Early reports claimed that Atlas was still on its hyperbolic trajectory, a one-way ticket through our solar system, curving around the sun before fading back into interstellar space. That was what everyone expected. After all, interstellar objects are not bound to the sun like comets born here. They arrive on trajectories that betray their alien origin, hyperbolic, fast, and unrepeatable. 3I Atlas was no exception. Yet as more observations came in after the CME, hints of irregularities began creeping into the data. The margins were small, so small they could be dismissed as observational noise. A fraction of an arcsecond here, a subtle delay in brightness curve there. But in orbital mechanics, small differences can spell large uncertainties over time. The possibility arose that Atlas had been nudged ever so slightly by its encounter with the sun's fury. And if that was true, then the object wasn't behaving as a passive lump of dust and ice. Something about its structure or composition had interacted with the solar plasma in a way no one had fully anticipated. The physics of such an event are tricky. A CME is a storm of magnetized plasma, a billion tons of charged particles moving at millions of miles an hour. When it collides with a comet, it does more than just heat the surface. It can strip away material, alter its coma, and even induce currents within the nucleus. If Atlas had cavities beneath its surface, the storm might have penetrated them, causing explosions that acted like miniature thrusters. A burst of gas or dust, even a small one, could impart a measurable change in momentum. But that alone may not explain what some astronomers believe they are seeing. Others speculated about magnetic effects. If Atlas carried metallic or ferromagnetic material, the CME's charged particles could have coupled with it directly, dragging it slightly off course. Such an interaction would be unprecedented at the scale of an interstellar comet, but not impossible. The universe is full of surprises, and Atlas had already proven itself a master of defiance. The problem was that no one had direct proof, just anomalies in the trajectory that grew harder to dismiss the more they were measured. The stakes of this debate were not academic. Trajectory determines everything. It tells us where Atlas will be, what planets it might pass near, and whether fragments, if they exist, pose any risk. Even a slight deviation could change the story dramatically. If Atlas had been nudged closer to Mars, its upcoming pass might bring it nearer to the red planet than previously thought. That would not only give scientists a unique observational opportunity, but also raise unsettling questions about potential impacts. Mars, unlike Earth, has no thick atmosphere to shield it. A fragment striking the surface could release energy on a planetary scale, stirring dust storms or even altering the climate. No one suggested Atlas was now on a collision course with Earth. The hyperbolic nature of its orbit made that virtually impossible. But the mere idea that an interstellar visitor could have its trajectory shifted by a solar storm was enough to rattle confidence. It suggested that these objects were not immune to forces we don't yet fully understand, and that their paths were more malleable than once believed. The image of the cosmos as a predictable clockwork began to fray at the edges. Complicating matters further was the brightness anomaly itself. The green glow that intensified after the CME altered how astronomers measured Atlas's position. Telescopes use reflected light to track objects, but when that light comes from unusual emissions rather than simple reflection, the calculations can skew. Was Atlas's orbit actually altered, or were the measurements deceived by its glowing coma? Distinguishing between the two required painstaking analysis, and the longer it glowed, the harder it became to isolate nucleus from halo. History offered eerie parallels. When Oumuamua was tracked in 2017, it too exhibited unexpected acceleration, deviating from its projected orbit without any visible cause. Scientists scrambled to explain it: outgassing, radiation pressure, or exotic shape. But nothing fit perfectly, leaving a residue of suspicion that perhaps something about interstellar objects resists neat categorization. Now, Atlas appeared to be following the same script. Trajectory deviations tied not to obvious mechanics, but to anomalies cloaked in mystery. Some researchers suggested that the CME event was a kind of natural experiment, a once-in-a-lifetime test of how interstellar matter responds to solar violence. If the trajectory shift could be measured and confirmed, it might reveal new physics about plasma interactions, cometary composition, or even the presence of exotic materials. Others, however, viewed it with unease. A body that can change course unpredictably under forces we cannot fully account for is a wildcard in cosmic terms. And if Atlas isn't the last interstellar visitor we'll see, and evidence suggests it won't be, the implications extend far beyond this single event. What unsettled many was not just the possibility of a nudge, but the timing once again. The trajectory questions emerged immediately after the CME, within the same window that Earth reeled under auroras and disruptions. If the anomalies were simply observational errors, why did they appear only after the strike? The pattern reinforced the sense that Atlas had not just survived, but had been altered in some fundamental way. For the wider public, such details rarely make headlines. Orbits and arcseconds do not capture attention like glowing green comets or fiery solar storms. Yet behind the scenes, in observatories and conference calls, the whispers grew louder. If Atlas's path was no longer the one originally predicted, what did that mean for the future of interstellar science? Could we truly trust our models when faced with objects that behave outside expected norms? Speculative voices went further still. They asked whether the trajectory anomalies were merely byproducts of plasma physics, or signals of something intentional. If one entertains the most radical theories, Atlas might not be entirely inert. Could its resilience, its glow, and its course all point to an engineered object, responding not as rock and ice, but as something designed to survive and adapt? These were dangerous questions in academic circles, but in the realm of speculation and public imagination, they flourished. For now, the official stance remains cautious. Atlas is still on a hyperbolic trajectory, still destined to leave the solar system after its brief visit. The deviations, if real, are small, too small to alter the ultimate fact of its escape. But small does not mean meaningless. Small is how anomalies begin, how mysteries reveal themselves, and small is sometimes all it takes to rewrite assumptions about the nature of the universe. The trajectory questions remain open, unsettled, and pressing. Atlas continues its path, glowing in defiance, while astronomers trace its motion with growing unease. Whether the CME nudged it or not, the fact that we cannot say with certainty is itself a revelation. These interstellar objects may not be the passive visitors we imagine. They may be shaped, shifted, and altered by forces we are only beginning to glimpse. And as Atlas moved onward, trailing whispers of possible fragments behind it, a new question emerged. Had the sun's strike split it apart after all, leaving behind shadows that could one day chart their own unpredictable courses? Split, shadow, or swarm. The moment astronomers began scrutinizing 3 Atlas after the solar strike, a troubling possibility surfaced. What if the object had not survived intact, but fractured? Survival is one thing. Endurance against the sun's fury is remarkable on its own. But the data that trickled in during the days after the CME hinted at something stranger. Faint signatures appeared in the images, dark clumps trailing the main body and irregular flickers of light as though the comet's glow was not coming from one nucleus but several. It raised the unsettling question. Had 3I Atlas split, and if so, what now followed it across the solar system? Fragmentation is not unusual for comets. In fact, it is expected. When comets near the sun, heat and tidal forces tear them apart with brutal efficiency. Comet Shoemaker-Levy 9 broke into dozens of pieces before plunging into Jupiter, each fragment slamming into the gas giant in a series of fireballs visible across the solar system. Even homegrown comets like Ison disintegrated spectacularly after close solar encounters. Fragility is the rule, yet here was Atlas, apparently intact, and yet perhaps not. Its central brightness remained strong, its nucleus seemingly whole, but the ghostly trails spotted behind it told a more complex story. The possibilities multiplied. One interpretation was that the CME impact had fractured the object, cracking off smaller pieces that now followed like satellites. If true, Atlas was no longer one traveler but many, a convoy of fragments streaking through space. Another view argued these were not solid pieces but dense knots of dust and plasma expelled during the flare. Still others suggested observational illusions, artifacts of instruments struggling to distinguish between the brilliant green coma and the background of stars. But the fact that multiple observatories reported the anomalies made dismissal difficult. What unnerved observers most was the pattern. The suspected fragments didn't disperse randomly. They seemed to cluster, drifting like shadows, almost as if tethered by invisible strings. Cometary fragments usually scatter, spreading along the orbital path in long trails. Atlas's companions, if real, appeared tighter, darker, and oddly cohesive. Were they natural chunks bound loosely by gravity? Or something more enigmatic? Dense cores that resisted dispersal even under solar assault. The swarm theory began to circulate. If Atlas had indeed fractured, then we were no longer tracking a single hyperbolic trajectory. We were dealing with a formation, and formations are far harder to predict. Each fragment could have its own spin, like its own jetting of gas, its own slight deviation in orbit. That means each fragment could drift away on a different path, some falling toward the sun, others bending outward toward the planets. The mathematics of such a system spiral into chaos quickly, and for mission planners or planetary defense experts, it is the stuff of nightmares. The swarm idea also tapped into a deeper unease. Since its discovery, Atlas had been compared to Oumuamua, and Oumuamua's odd acceleration had led some scientists to toy with radical theories of artificial origin. If one entertains those whispers, then the idea of Atlas fragmenting into a coordinated swarm becomes almost too provocative. Natural or not, the visual of an interstellar object splitting into multiple parts, each glowing with the same uncanny hue, triggered speculation well beyond academic circles. Could it be seeding? Could it be designed to multiply, to release offspring into the solar system like spores carried on a stellar wind? Mainstream voices pushed back hard. There is no evidence of artificial behavior, became the refrain. And scientifically, it was correct. Dust clouds and fragments behave in unpredictable ways, and confirmation of actual bodies was still lacking. Yet the doubt remained, fanned by timing and coincidence once again. The CME strikes, Atlas brightens, and suddenly faint shadows trail behind it. The pattern was too neat to ignore. For planetary scientists, the stakes were pragmatic. If fragments existed, they had to be cataloged and tracked. Even small pieces, if nudged onto new courses, could become meteors or impacts years down the line. Mars was the immediate focus. Atlas's trajectory already brought it closer to the red planet than to any other world. If fragments trailed it, Mars might soon find itself in their path. The idea of watching interstellar debris strike another planet was thrilling scientifically, but unsettling in implication. A collision could stir global dust storms, release energy on the scale of nuclear detonations, and leave scars visible for centuries. The swarm debate also forced a reconsideration of cometary resilience. If Atlas fractured but retained a central core, then it was not destroyed, it adapted. Fragments that remained clustered could suggest unusual cohesion, perhaps a denser internal structure than expected. It might be a rubble pile bound by more than gravity, maybe electrostatic forces, or even metallic composition that allowed chunks to remain tethered. Such possibilities push the boundaries of known cometary physics, hinting that interstellar bodies may be built differently from anything born in our system. Images of the suspected fragments were murky, grainy, hard to parse, but even in their ambiguity, they fueled narrative. Some astronomers compared them to a school of fish darting behind a leader. Others described them as shadows, darker than the glow around them, almost invisible until one knew where to look. These metaphors revealed a struggle to describe what didn't fit expectations. Comets are supposed to behave in familiar ways. Atlas didn't. It was a green survivor now possibly multiplying into a convoy. The public imagination seized on the idea. Forums buzzed with theories of star seeds, of alien craft hidden in cometary shells, of cosmic spores spreading life. Scientists groaned, but history shows that anomalies inevitably breed speculation. And if speculation thrives here, it is because the facts themselves remain uncertain. Atlas did not follow the script, and in that uncertainty, imagination flourishes. Even within sober scientific circles, the implications of a swarm were daunting. Tracking one interstellar object is challenging but possible. Tracking multiple fragments, each with slightly different dynamics, is almost impossible with current technology. If Atlas had indeed become a swarm, then this was a scenario where science had to accept ambiguity. We may never know exactly how many fragments were created, where they drifted, or what paths they now follow. Some could escape into interstellar space, never to be seen again. Others could linger in the solar system for decades, faint shadows of an alien visitor haunting planetary orbits. The question then becomes, what does it mean for the future? If interstellar objects tend to fracture and swarm under stress, then perhaps our solar system has already been seeded with fragments from past visitors. Could some asteroids we classify as native actually be remnants of interstellar travelers long forgotten? Could Earth itself have been touched, seeded, or scarred by such swarms in ancient epochs? These questions stretch beyond hard data, but they sit at the edges of the debate, fueled by every fresh anomaly Atlas presents. In the end, whether Atlas split into a swarm, shed fragments, or simply played tricks with light, the uncertainty is the story. The shadows may be dust, they may be rocks, or they may be nothing more than illusions. But in those uncertainties lies the reason Atlas captivates. It refuses to be ordinary. First, it survived the sun. Then it glowed green against all expectations. Now it may have multiplied, becoming more than one, leaving scientists to wonder if the visitor from the stars is a single body or a caravan of enigmas. And if the swarm is real, then the real story is just beginning. Because every fragment carries the same mystery as the parent body, and each one is now free to carve its own unpredictable path through the solar system. The sun's strike may not have ended Atlas's journey, it may have multiplied it. And as those fragments fade into the darkness or collide with unsuspecting worlds, we are left to confront a chilling possibility. When an interstellar visitor comes under fire, it doesn't die, it multiplies. Echoes of Oumuamua. For many astronomers, the mystery of Three-Eye Atlas cannot be disentangled from the shadow of its infamous predecessor, One-Eye Oumuamua. When Oumuamua streaked into our solar system in 2017, it rewrote the script of astronomy overnight. Before that moment, interstellar objects were purely theoretical, fascinating to imagine but unproven. When the first one was finally observed, it refused to play by the rules. It didn't glow with a comet's coma, didn't trail a tail of gas and dust, and it didn't even look like anything we had cataloged before. Instead, it reflected sunlight erratically, its brightness flickering as though it were elongated, like a shard or a flattened pancake, tumbling in space. And then came the anomaly that made Oumuamua infamous. It accelerated, drifting away from its predicted orbit as if pushed by a subtle, invisible hand. For months, scientists scrambled to explain the acceleration. Some said it was outgassing, though no jets of vapor were ever detected. Others proposed radiation pressure, with sunlight nudging the object like a solar sail. Still others quietly wondered if we were staring at something artificial, an object engineered to harness starlight for propulsion. The debate grew heated, and though the artificial theory was never accepted officially, it remained lodged in the public imagination. Oumuamua became less a scientific discovery than a cultural phenomenon, proof that even the most rational field can stumble when confronted with something truly alien. When 3I Atlas was first spotted, it was immediately compared to Oumuamua. A second interstellar visitor in less than a decade was astonishing enough, but from the start, Atlas brought its own oddities. Where Oumuamua was silent and tailless, Atlas glowed with a strange green aura. Where Oumuamua accelerated mysteriously in the absence of visible outgassing, Atlas flared and brightened in ways that defied cometary chemistry. And now, after surviving a solar strike, Atlas seemed to echo Oumuamua's legacy in the most unsettling way. It too was behaving as though natural physics could not fully account for its path. The parallels were too strong to ignore. Oumuamua had its acceleration anomaly. Atlas had its potential trajectory nudge after the CME. Oumuamua had its odd reflections. Atlas had its spectral glow. Both emerged from the interstellar dark, both refused to conform to categories, and both left scientists split between mundane explanations and speculative leaps. The echoes were not just in behavior, but in the way the scientific community responded, cautiously, defensively, and with a lingering undercurrent of unease. For those who believe in patterns, the similarities suggest that these visitors may share more than just origin. Perhaps interstellar bodies are inherently anomalous. Perhaps our solar system is simply unprepared to interpret matter forged under alien stars. The chemistry, density, and structure of such bodies might differ so radically from anything we know that anomalies are inevitable. And yet, the timing of Atlas's anomalies, directly after a solar storms, when Earth was already ablaze with auroras, feels less like coincidence and more like choreography. This was precisely the kind of eerie synchronicity that surrounded Oumuamua as well. An object appearing seemingly out of nowhere, staying just long enough to puzzle us, and then vanishing into the void before we could pin it down. Oumuamua left unanswered questions that haunt the Atlas discussion. If Oumuamua wasn't a comet or asteroid as we know them, then what was it? Some proposed a fragment of a shattered planet, a sliver of interstellar debris flung from a distant system. Others speculated it might have been composed of exotic ices, hydrogen or nitrogen, that evaporated invisibly, producing thrust without leaving a visible tail. Each hypothesis solved one mystery, but created others. And now Atlas has arrived to reopen every wound. If it too defies classification, if it too resists neat explanation, then maybe the real problem isn't with the objects, but with our assumptions. Perhaps the solar system isn't prepared for what interstellar space is sending our way. The comparison grows darker when considering how quickly both objects passed from sight. Oumuamua was detected late, so late that by the time telescopes turned toward it, it was already on its way out. We were spectators chasing shadows. Atlas, though discovered earlier, is still fleeting. Its time in the inner solar system is brief, its mysteries compressed into a handful of months before it disappears forever. In both cases, humanity is left grasping at fragments of data, trying to reconstruct meaning from incomplete glimpses. This is not how science prefers to operate, and it feeds the sense of unease. Speculative voices seize on the echoes between them. If both Oumuamua and Atlas show signs of resilience, if both exhibit anomalies in motion or brightness, could they be part of a pattern larger than coincidence? Could interstellar space be filled not with random debris, but with objects that are different by design, or at least by nature in ways we don't yet comprehend? Some dare to wonder whether we are seeing the edges of an interstellar population, objects that serve purposes we cannot guess, scattering between stars like seeds on the cosmic wind. Culturally, the echoes are just as strong. Oumuamua thrust into headlines, documentaries, and endless debates about alien technology. Atlas has not yet drawn the same public frenzy, but the signs are there. The green glow, the solar strike, the whispers of fragments trailing behind. It all feels like a sequel, continuation of a narrative humanity is only beginning to recognize. And if the first story raised the possibility of artificiality, the second raises the possibility of resilience. Together they suggest a thread, a continuity that hints at interstellar visitors as recurring messengers rather than random accidents. Scientists wrestle with this in private. To admit too much invites ridicule. To admit too little ignores the strangeness staring back at them. Some have begun calling Atlas Oumuamua's twin, though not in public papers. The twinship lies not in appearance, but in effect. Objects that refuse classification, objects that appear briefly and leave lasting confusion, objects that remind us how little we know about what drifts between the stars. And yet, there is an important difference. Oumuamua slipped by without ever being touched. It glided through the solar system unscathed, mysterious but untouchable. Atlas, on the other hand, has been tested. The sun itself hurled its fury at it, and still it endured. That resilience may be the most important echo of all, not a mirror of behavior, but a rhyme, a continuation of the theme that interstellar visitors are built differently, and that difference may be the key to understanding them. The unsettling part is this: we are 2 for 2. Both interstellar objects observed so far have behaved in ways that defy standard cometary or asteroid models. Not one has conformed to expectation. Statistically, that is bizarre. If interstellar objects were just cosmic rubble, we would expect most of them to behave predictably. Instead, every one we've seen has forced us to reconsider the fundamentals, which leads to a chilling possibility. What if the anomalous is not the exception, but the rule? What if every interstellar visitor is strange and we are only beginning to see the pattern? If so, the echoes of Oumuamua are not just historical, they are prophetic. They remind us that Atlas is not a fluke, not an outlier, but part of a chain. Each visitor may be a chapter in a cosmic story we are only now beginning to read. The question is whether we will recognize the narrative before it passes us by once again. Because just like Oumuamua, Atlas will not linger. Its trajectory is hyperbolic. It will not return. The mysteries it carries, fragments, glow, resilience, will vanish into the dark beyond the planets, leaving us only with data, debates, and unease. And when the next interstellar object arrives, as it surely will, the echoes will grow louder still. We will not be able to dismiss them as coincidence anymore. Oumuamua was the warning. Atlas is the reminder. Together, they whisper of a cosmos far stranger than we have dared to admit, and of visitors who come not to stay, but to leave us questioning what else might be on the way. Energy that doesn't add up. To understand why 3I Atlas continues to baffle astronomers, one must begin with scale. A coronal mass ejection is not just a solar breeze or a puff of plasma, it is one of the most powerful natural forces in the solar system. A single CME can hurl billions of tons of charged particles into space, moving at speeds of up to several million miles per hour. The energy released in such an event dwarfs anything humanity can conceive of building. In fact, one strong CME can unleash the equivalent of 1 billion nuclear bombs detonating simultaneously. These are forces that bend planetary magnetospheres, trigger global auroras, and threaten the stability of Earth's electrical grid. Now picture a fragile comet. These icy wanderers are usually porous, lightweight, loosely packed collections of dust and frozen gases. Even modest sunlight can cause them to break apart. Tidal forces from a planet can rip them into pieces. Minor outbursts can crack their nuclei like glass. Against the raw energy of a CME, such an object should stand no chance. It should vaporize instantly, or at least fragment into a chaotic trail of debris. Yet 3I Atlas did not. It endured a direct strike and somehow emerged brighter, more visible, almost invigorated. That contradiction is what leaves scientists unsettled, because the energy simply does not add up. The simplest explanation is that the object is not as fragile as we assumed. Perhaps Atlas is denser, more cohesive, or built of exotic materials uncommon in our local system. If its core were metallic or crystalline instead of porous, it might shrug off impacts that would obliterate a typical comet. But this raises new questions. Why would an interstellar comet be so different in composition? Did it form in an unusually violent system, like where only the most resilient matter survived? Or does it represent an entirely new category of interstellar traveler, forged under conditions alien to anything we know? The mystery deepens when considering the nature of plasma interactions. A CME is not just heat and radiation, it is magnetized matter. When it collides with another object, the effect depends not only on size, but also on structure, conductivity, and magnetism. If Atlas carried metallic components or superconductive phases, the plasma might have flowed around it rather than through it, sparing the nucleus while exciting its surface to glow. In that sense, the green aura may be less a coma of gas and more a plasma sheath, a visible discharge of energy absorbed and re-emitted. This theory excites plasma physicists but unsettles astronomers because it implies Atlas has properties far beyond our catalog of natural comets. There is also the issue of momentum. The kinetic energy of a CME striking an object at those speeds should have imparted some push, however slight. And indeed, as later observations suggested, Atlas's trajectory may have shifted. But here, too, the numbers do not add up. The amount of deviation measured or suspected seems too large to be explained by simple surface drag. Either the CME interacted with the body more directly than models predict, or something about Atlas amplified the effect. Did cavities within the comet act as chambers, focusing the plasma and expelling it explosively like thrusters? If so, why was the object not shattered? Survival in such a scenario seems almost paradoxical, to be pushed without being destroyed, to absorb energy without collapsing. Even within the realm of natural explanations, the energy mismatch is glaring. In past cases, comets struck by solar storms have behaved predictably: outbursts, fragmentation, fading. They respond as fragile snowballs in the blast furnace of the sun. Atlas broke that pattern. The lack of debris clouds, the persistence of brightness, the coherence of its form, these all suggest an interaction that absorbed catastrophic energy and somehow transformed it into visibility rather than destruction. Speculative thinkers point out that this is exactly the kind of phenomenon that would mimic energy management, almost as if the object were engineered. A structure designed to endure stellar radiation might redirect energy into emission bands rather than heat. The green glow, persistent and spectral, could be seen as evidence of this. Such ideas remain fringe, but the unsettling mismatch between input energy and output behavior gives them fuel. After all, science thrives on proportionality. The force applied should correspond to the effect observed. When the relationship breaks, imagination rushes in to fill the void. The anomaly also poses questions for planetary defense. If an interstellar body can endure a CME of such magnitude, what does that say about our ability to deflect or destroy similar objects if one ever threatened Earth? Our most powerful weapons pale in comparison to the sun's fury. Yet, Atlas survived what would have been a death blow for any man-made structure or native comet. This resilience complicates the calculus of impact risk. Perhaps some interstellar visitors are not just wanderers, but indestructible projectiles, immune to the very forces we assumed would neutralize them. Looking deeper, some theorists compare Atlas's survival to the behavior of Oumuamua. There, too, energy seemed mismatched. A subtle but persistent acceleration occurred without visible cause, as if Oumuamua were being propelled by forces invisible to standard comet models. With Atlas, we again see an energy puzzle. Immense solar force yields the wrong kind of response. Both cases underscore a theme that interstellar objects obey rules we do not yet understand. They are not anomalous outliers, but perhaps representatives of a broader class, governed by physics that has not yet been fully integrated into our models. Cultural echoes also emerge. Ancient traditions speak of starstones and green visitors that survive the anger of the sun. To modern ears, these sound like myths. Yet when a glowing green traveler withstands the most violent eruption our star can deliver, those myths suddenly read like historical footnotes to a phenomenon we are watching unfold today. Could ancient witnesses have seen interstellar visitors that, like Atlas, defied destruction and flared brighter in the aftermath? Could the mismatch of energy and survival have left impressions so profound they became woven into legend? The mismatch also unsettles at a philosophical level. Humanity relies on energy balances to explain the universe. Conservation laws, thermodynamics, proportionality, these are bedrocks of science. When faced with an object that absorbs energy without responding proportionally, the foundations tremble. The disquiet comes not just from not knowing, but from sensing that our frameworks themselves may be inadequate. If interstellar visitors routinely survive forces we deem catastrophic, then perhaps our understanding of energy transfer is incomplete. Perhaps new states of matter, new kinds of bonding, or even new physical principles await discovery. Still, skepticism endures. Some scientists argue the mismatch may be an illusion created by poor observation. Perhaps Atlas did fragment, but the debris is too faint to detect. Perhaps the glow is exaggerated by instrument error, the trajectory shift a statistical quirk. In this view, the mystery will dissolve with better data, as most mysteries do. Yet the counter-argument is persuasive. Anomalies have now appeared in every interstellar object we've seen. If all we needed was better data, why do the mysteries keep multiplying? For now, the energy problem remains unresolved. Atlas continues on its course, glowing defiantly, leaving astronomers to puzzle over how it withstood a solar storm that should have annihilated it. The mismatch between what should have happened and what did happen fuels both scientific inquiry and speculative wonder. Energy was unleashed. The math is clear, but the outcomes don't align. And so, as Atlas drifts onward, it leaves behind not just a glowing green trail, but a lingering unease. How did it survive when it should have died? How did catastrophic energy become light instead of destruction? These questions hang in the sky like the object itself, a luminous riddle, daring us to solve it. But survival and glow are only part of the enigma. Beneath them lies another puzzle, one tied to the invisible forces of magnetism and plasma. If energy transfer does not add up, perhaps it is because Atlas carries hidden properties that interact with solar storms in ways we have yet to imagine. Which leads to the next question. Was it the sun's fury that revealed Atlas's strength, or was it Atlas's nature that revealed something new about the sun? Magnetic field mystery. When the sun lashes out with a coronal mass ejection, it does not merely throw heat and light into space. It hurls magnetized plasma, vast clouds of charged particles threaded with twisted fields. These magnetic ropes stretch and snap, bending across millions of miles. And when they strike an object, they do not behave like ordinary winds. They couple, they wrap, they induce currents that can burn out electronics and distort entire planetary magnetospheres. Earth is shielded by its magnetic field, a bubble that deflects much of the storm. Mars, stripped of its protective magnetosphere long ago, suffers directly from the sun's temper. Small bodies like comets and asteroids, fragile and unprotected, usually disintegrate. Yet 3i Atlas survived, and in its survival it whispered of a possibility most scientists are reluctant to say out loud. Did it somehow have a magnetic shield of its own? The idea sounds absurd at first. Comets are not planets. They are not dynamos generating molten cores of iron, spinning currents that produce protective fields. But the evidence gnaws at certainty. Atlas was struck head-on by a CME so powerful it could have crippled our satellites had it been aimed at Earth. The magnetic turbulence should have ripped gas and dust away, peeling the object layer by layer until only fragments remained. Instead, telescopes recorded coherence. Not only did Atlas hold itself together, but its glow intensified, as though the storm had energized it. One explanation is that Atlas carries a metallic or ferromagnetic core, perhaps the remains of some planetary fragment ejected from another star system. If so, then the CME's charged particles may have interacted with that core in ways we've never observed in comets before. A metallic heart could induce eddy currents, generating a temporary field strong enough to redirect plasma around it, like a shield. In this model, Atlas becomes less a fragile snowball and more a cosmic capacitor, briefly charged by the storm and glowing in the aftermath. If true, this would rewrite assumptions about interstellar objects. No comet we've observed locally carries such a dense metallic signature. Our system's comets are remnants of icy disks, lightweight and porous. For Atlas to carry a magnetic skeleton suggests a birthplace in a far harsher crucible, perhaps near a dying star or as shrapnel from a cataclysmic planetary collision. Its journey across interstellar space may have preserved that resilience, leaving us to wonder whether we are seeing the first of many such armored travelers. But there is another, more unsettling interpretation. Some plasma physicists note that Atlas's green glow after the CME looked less like ordinary sublimation and more like auroral activity, particles spiraling along invisible lines, glowing as they shed energy. Earth's auroras, after all, are caused by charged solar particles interacting with our magnetic field, funneling toward the poles. Could Atlas's aura be a miniature version of this, hinting at magnetism structured enough to guide energy into visible light? If so, then the object didn't just survive the storm, it danced with it. Skeptics dismiss this as overreach. A comet is too small, they argue, to sustain a field strong enough to mimic planetary auroras. Yet they cannot fully explain why the glow intensified instead of fading, or why reports of fragments remained ambiguous. If the field were real, it could have contained material close to the nucleus, preventing dispersion and keeping the object coherent. The very thing that should have shredded it instead left it brighter and strangely intact. The magnetic question also loops back to trajectory. If Atlas's core interacted magnetically with the CME, then the push it received may not have been mechanical at all. Instead of being nudged by momentum transfer, it may have been dragged along field lines, shifting its orbit in subtle but profound ways. That would explain why deviations were noted that did not match expectations from simple physics. The sun's fury and Atlas's resilience may have combined into a magnetic handshake, altering the visitor's path in ways no one predicted. If magnetic resilience exists in Atlas, then what does that mean for our understanding of interstellar space? Perhaps fields are more common out there than we realize. Perhaps small bodies can carry remnants of magnetism from their parent systems, fossilized fields that remain coherent across millions of years. Or perhaps Atlas is unique, a freak survivor of conditions we do not yet know how to imagine. Either way, it suggests that when interstellar visitors arrive, they may bring not only strange chemistry, but strange physics as well. The whispers grow louder when comparisons are made to Oumuamua. Its acceleration anomaly was never explained satisfactorily. Outgassing without jets seemed contrived. Radiation pressure required an object thinner than paper. But what if magnetism played a role there too? If Oumuamua carried a remnant field or conductive properties, it might have interacted with solar wind in subtle ways, producing acceleration without visible exhaust. If so, then Atlas's resilience under a CME is not a unique miracle, but the second data point in a pattern. Cultural resonance amplifies the mystery. Ancient traditions often spoke of sky stones that resisted fire, glowing green as they passed overhead. In some texts, these stones were described as shields or weapons of the gods, impervious to the sun's wrath. To modern ears, these are myths. Yet when one watches Atlas defy a solar storm, glowing emerald in the aftermath, it is hard not to hear echoes of those stories. Could they have been inspired by past encounters with interstellar bodies carrying hidden fields, their resilience misinterpreted as divine? The speculation deepens in uncomfortable directions. If Atlas is magnetic, and if its glow is auroral in nature, then it is not only enduring the sun, it is communicating its resilience visibly. Some ask the forbidden question: could this be intentional? Could we be watching not a natural accident of physics, but a demonstration, a show of endurance scripted across cosmic scales? Mainstream science recoils at such ideas, yet the silence surrounding official reports does little to quiet them. The less we are told, the more imagination fills the gaps. Even if entirely natural, the implications remain staggering. A comet that can generate or retain a magnetic field challenges assumptions about small body physics. It suggests that resilience to solar storms is not impossible, but a feature we may encounter again. It implies that the universe is filled with objects that look fragile but are armored by forces invisible to our eyes. For planetary defense, this is both a reassurance and a warning. Reassurance because magnetized bodies may deflect plasma instead of amplifying it toward Earth. Warning because such bodies may also resist any attempt to deflect them should one ever wander too close. Ultimately, the mystery is not whether Atlas has a magnetic field, but whether we can ever prove it. Its time in our skies is short. Data is limited, observations contested, interpretations fragmented. By the time the debate coalesces, Atlas will be gone, vanishing into the interstellar dark. All that will remain are notes, images, and the glow of memory. A reminder that for one brief moment, a visitor from the stars stood against the fury of the sun and emerged shining green, as if armored by a field of its own. And so, the mystery lingers. Was Atlas a fragile comet lucky enough to endure, or a magnetized traveler revealing a property we never thought possible? The difference is profound. Because if it is the latter, then the next interstellar visitor may not just carry ice and dust, it may carry secrets of magnetism forged in alien skies, waiting to test itself against our sun. And when it does, we may no longer be able to dismiss the resilience as chance. It may be the rule, not the exception. But before we can grasp what that resilience means, another puzzle calls. If Atlas endured, if it glowed, and if it hinted at hidden magnetism, then why did these events coincide so precisely with seismic unrest and solar chaos on Earth? Was it coincidence, or another clue that timing itself may be part of the message? Coincidence with earthly unrest. When a solar storm collides with an interstellar visitor, the drama seems confined to space. Plasma flows, magnetic fields twist, light flares, and astronomers record it all in data streams. But the strange case of Three Eyes Atlas is not remembered solely for what happened in the void. It is remembered for the timing here on Earth. The days surrounding the CME strike were not calm on our planet. They were marked by upheaval. Auroras far south of their usual haunts, technological disturbances, and a wave of seismic and volcanic activity that seemed almost synchronized with the sun's outburst. Officially, these events are coincidences. Yet the pattern is unnerving, and once seen, it is difficult to dismiss. The auroras came first. Even before the CME that slammed into Atlas, Earth was already on edge from a string of solar storms. Skywatchers from Canada to France reported curtains of green and purple light dancing overhead, some visible to the naked eye in places where auroras are a once-in-a-lifetime event. Social media filled with images, rural towns glowing with eerie light, entire city skylines crowned by waves of color. Scientists explained it with the usual language: geomagnetic storms, charged particles funneled by Earth's magnetic field. Yet the timing was striking. The sun's fury was rising not in a gentle curve, but in sudden bursts as though building toward something. And just as it reached a peak, the CME aimed squarely at Three Eye Atlas erupted. As the comet took its hit in deep space, Earth endured its own manifestations. Airlines rerouted polar flights to avoid radiation risks. GPS systems registered minor errors. Amateur radio operators reported blackouts. But what unsettled observers most was what came next. The ground itself began to tremble. Within days of the CME strike, a significant earthquake rattled Venezuela. Not long after, tremors struck elsewhere along the Pacific Rim. Almost simultaneously, volcanic activity flared in multiple regions, plumes of ash rising from restless peaks, some after years of relative quiet. Geologists were quick to insist there was no causal link. Tectonic plates shift according to their own hidden clocks. Volcanic magma rises and falls independent of solar winds. Earthquakes, they say, do not consult the sky before striking. Yet, even as they reassured the public, the juxtaposition was haunting. Solar chaos above, seismic unrest below, with an interstellar visitor caught in the middle of the timeline. The coincidences piled up too neatly, like dominoes arranged in a row. The scientific community has long wrestled with this problem. The human mind craves patterns. Our survival once depended on noticing connections. Storm clouds before rain, animal tracks before danger. But this instinct betrays us in science, where random events often cluster without meaning. Still, even seasoned scientists admitted unease. The clustering of solar storms, auroras, earthquakes, and volcanic flares within such a narrow window could not be ignored. The very phrase "no proven link" carried the silent admission that correlation was undeniable, even if causation was elusive. Theories, of course, emerged. Some pointed to the idea of solar-terrestrial coupling. While the sun cannot directly cause earthquakes, changes in geomagnetism might influence Earth's ionosphere, which in turn could stress the crust in subtle, poorly understood ways. Others resurrected fringe notions of electroseismic effects, long dismissed but occasionally re-examined when coincidences like this occur. More imaginative minds propose that interstellar bodies themselves carry influences, gravitational, magnetic, even metaphysical, that ripple through the solar system when they interact with the sun. These ideas lacked proof, but their allure was undeniable. The public was not blind to the timing either. Forums buzzed with talk of omens, of cosmic warnings. Some recalled prophecies of green stars heralding unrest. Others tied the events to cycles of history, noting that civilizations have long linked comets with earthquakes, rulers with eclipses, and solar storms with catastrophe. Ancient chronicles are littered with passages where sky and earth respond together, disasters above mirrored by disasters below. Perhaps those chroniclers were not wrong, but simply recording patterns too subtle for modern science to measure. For those tracking Atlas, the timing seemed even more loaded. This was not just any comet. It was the third confirmed interstellar visitor arriving from beyond the neighborhood of our sun. Its presence was already improbable. That it should coincide with a solar storm of rare intensity was stranger still. And that the storm's aftermath aligned with earthly unrest felt almost scripted, as though the universe had arranged a drama too theatrical to be real. Yet it was real, unfolding day by day in news headlines, seismographs, and aurora photos. Some astronomers quietly noted that similar coincidences had occurred before. The Carrington event of 1859, the most powerful geomagnetic storm in recorded history, was followed by unusual seismic activity across multiple regions. Smaller solar storms in the 20th century had coincided with volcanic flares. Each time, scientists dismissed the link. But taken together, a pattern begins to whisper. Perhaps the sun's storms do more than we know. Perhaps their energy couples with Earth in ways deeper than magnetospheres and power grids. If so, then Atlas's ordeal was not isolated. It was part of a wider storm that rippled across both sky and ground. The coincidence also touches on psychology. Humans are wired to seek meaning. A green-glowing interstellar comet struck by the sun while Earth trembles is too rich a tableau to leave unexplained. Even if science ultimately proves no connection, the cultural impact is already sealed. People will remember the week Atlas survived as the week the Earth shook. They will tell stories of a cosmic visitor and terrestrial unrest, binding them together in narrative. And that narrative will echo in myth, prophecy, and speculation long after the scientific reports have faded. Yet one cannot shake the feeling that timing itself is the message. If Atlas had been struck in a quiet week, with Earth calm and skies ordinary, it would be extraordinary still, but not uncanny. What makes it uncanny is that it happened when everything else was already charged. The auroras were blazing, the quakes were rumbling, the volcanoes were restless. And into that mix came the survival of an object that should have died, glowing brighter instead. It is not just coincidence. It is coincidence with teeth, the kind that gnaws at rational explanations and leaves a taste of mystery. The silence of official channels only heightens the effect. NASA, ESA, and other agencies reported the solar storms. They reported the auroras, they reported the quakes and volcanoes as separate news. But almost no one spoke of the fact that all of this occurred together, tied by time to a comet from the stars. By refusing to frame it as a pattern, they left the pattern free to grow in the public imagination. And once imagination is lit, it does not go out. The ultimate question is whether this timing was pure chance or part of a hidden order. Science for now leans on chance, but history suggests caution. Many great discoveries began with coincidences too strange to ignore. Falling apples, wandering planets, unexpected sparks. Coincidence is often the doorway to truth. And if this coincidence hides truth, it may be that solar storms, interstellar visitors, and Earth itself are linked by threads we cannot yet measure. For those who witnessed it, the memory is fixed. September skies alive with light, Earth trembling, and a green survivor glowing against the darkness. Whether coincidence or connection, it left an impression that will not fade. Atlas's resilience is part of the story, but so too is Earth's unrest. Together they form a tableau, a snapshot of a universe in motion, as if sky and ground conspired to remind us that we live not in isolation, but in a web of forces that may be deeper, stranger, and more connected than we dare believe. And just as the coincidence on Earth unnerved observers, a parallel mystery unfolded in space. Atlas's glow did not trail away like a normal comet's tail. Instead, something strange appeared, a sunward stream of light, a so-called anti-tail, that seemed to defy physics. If Earth's unrest was coincidence, could the comet's defiance be another? Or was it evidence that the mysteries were multiplying? The next revelation would push the limits of cometary science and speculation further still. The anti-tail phenomenon. One of the most striking mysteries surrounding 3 Atlas was not its survival under the sun's fury, nor even its eerie emerald glow. It was the direction of its tail. In the language of comet science, this is where certainty meets spectacle. A comet's tail, as every astronomy textbook insists, always points away from the sun. This is not a matter of trajectory, but of physics. The solar wind, streams of charged particles radiating outward, blows dust and gas into space, forming the familiar trailing plumes. Whether a comet is moving toward or away from the sun, its tail stretches out in the opposite direction of the star, a banner of vaporized ice marking its surrender to radiation pressure. But 3 Atlas did something comets are not supposed to do. Observers recorded a tail that seemed to point toward the sun, a luminous stream of particles flowing back against expectation. In cometary science, this is known as an anti-tail. While not unheard of, anti-tails are rare, delicate, and usually fleeting optical illusions, caused when Earth passes through the orbital plane of a comet, creating a projection effect that makes dust trails appear reversed. Yet with Atlas, the anti-tail looked too bright, too persistent, and too perfectly timed with the CME strike to be dismissed as mere geometry. The images told a story at odds with the textbooks. While one side of Atlas streamed the expected faint dust plume away from the sun, a second, sharper structure shot sunward. It glowed, not diffuse and smoky like a dust trail, but narrow and almost solid, like a beam. Some astronomers speculated it was debris caught in unique orbital alignment, but others whispered that it looked eerily like controlled emission, as though the comet was venting energy toward the very star that had just tested it. The phenomenon drew immediate comparisons to earlier anomalies. Comet Arend-Roland in 1957 showed a similar feature, stunning observers at the time. But those anti-tails were short-lived, quickly fading as viewing angles shifted. Atlases persisted. Even after accounting for Earth's vantage point, the sunward feature remained conspicuous, a green-tinged spear pointing defiantly at the source of its torment. For plasma physicists, the puzzle deepened. Solar winds should push material outward. For dust or gas to stream inward requires forces acting against that current. Could Atlas's own magnetic properties, hinted at in earlier observations, be funneling particles back toward the sun? If so, then Atlas was not merely passive, it was interacting dynamically with the solar wind, shaping it, perhaps even resisting it. This was unheard of for a comet, and yet the evidence glowed across telescope images, undeniable in its strangeness. Speculation spread quickly. Some argued that the anti-tail was evidence of fragmentation, that Atlas had split and the sunward beam was simply a debris trail angled toward us. But the structure's sharpness contradicted this. Fragment trails disperse, this one concentrated. Others suggested exotic chemistry, particles ionized in unusual ways, bending under electromagnetic influence. But again, the persistence baffled. Such emissions should vary, flare, and fade. Atlas's anti-tail looked almost deliberate. And here, inevitably, the whispers of Oumuamua returned. That object, too, had defied physics by accelerating without visible cause. Some theorized it might have been propelled like a solar sail, catching light to change its speed. Atlas, glowing green and streaming material sunward, seemed to hint at something equally provocative. What if interstellar visitors are not only resilient, but reactive? What if they respond to stellar energy in ways that mimic control, as though designed to harness it? Mainstream science recoils at such language, but history shows that anomalies invite radical thought. The anti-tail became a Rorschach test. To some, it was geometry. To others, exotic plasma. To still others, a hint of technology cloaked as nature. The timing only fanned the flames. The anti-tail emerged immediately after the CME strike, as if the sun's fury had awakened something dormant within Atlas. Coincidence? Perhaps. But the chain of coincidences had grown long already. Even the cultural echoes are haunting. Ancient texts often describe arrows of light fired from stars, or stones with 2 flames, one backward and one forward. Historians usually interpret these as poetic exaggerations of comets. Yet Atlas's anti-tail looked exactly like those depictions, a double-tailed wanderer, one plume trailing the void, the other defying the sun. Could our ancestors have witnessed similar visitors, remembered in myth but forgotten in science? Practical implications, too, are unsettling. If interstellar objects can produce anti-tails not as illusions but as real emissions, then their composition is fundamentally different from local comets. This changes how we model their trajectories, their chemistry, even their potential as carriers of life or technology. An anti-tail may not just be a curiosity, it may be a signature, a marker of interstellar origin. And if so, then Atlas is not just the third interstellar visitor, It is the first to reveal itself with a beacon pointed straight at the sun. The phenomenon also reignites debates about panspermia. If comets carry the seeds of life across the stars, then how they interact with solar winds matters deeply. Could an anti-tail be a way of ejecting material sunward, seeding planets that lie between a comet and its star? If so, Atlas might not just be a wanderer, it might be a vector, a courier of dust, organics, or even microbes, released deliberately or by design of physics we barely comprehend. The anti-tail could be less about optics and more about biology, written in plasma and green light. Skeptics remind us that not every anomaly is profound. Anti-tails have been observed before, and projection effects explain much. Yet Atlas resists easy classification. Its glow, its resilience, its possible fragments, and now its anti-tail form a pattern of defiance. Each anomaly alone could be explained. Together they suggest something larger, a constellation of mysteries orbiting a single interstellar body. As Atlas drifts farther from the sun, the anti-tail may fade. The geometry will shift, the glow will dim, and the object will vanish into the dark between stars. But the questions remain. Why did its anti-tail glow so vividly, so persistently, and so provocatively? Why did it appear in the very days Earth trembled and the sun raged? Why does every interstellar visitor we meet leave us more confused than before? Perhaps the anti-tail is a message not of intent, but of ignorance, reminding us that we do not yet understand the universe we inhabit. Or perhaps it is more than that, a demonstration, an anomaly that forces us to consider possibilities we would rather avoid. Whatever it is, the image of a green comet firing a luminous beam back at the sun will linger. It is an image of defiance, of survival, of mystery. And just as the anti-tail unsettled astronomers, another layer of the story unfolded, not in plasma, but in silence. Because as the anomaly spread through observatories and private reports, major agencies remained curiously quiet. Technical notes trickled out, but the phenomenon received little mainstream coverage. Was it caution, fear of fueling speculation, or something else, an unwillingness to frame the anomaly in public at all? The next mystery in Atlas's journey was not about light or dust, but about the silence of those who should have spoken loudest, voices in the astronomical community. When 3i Atlas was first cataloged, it was a curiosity. Another interstellar visitor, another chance to gather data, another fleeting moment to test the boundaries of what we know about cosmic debris. But after the coronal mass ejections struck, after the green glow intensified, after whispers of fragments and anti-tails began to spread, the astronomical community found itself caught between two instincts: to interpret with caution and to admit that something extraordinary might be unfolding. Publicly, the official tone was calm. NASA bulletins noted unusual activity. The European Southern Observatory referred to enhanced brightness. Peer-reviewed papers used language like possible non-gravitational perturbations and uncharacteristic coma behavior. The words were technical, precise, and bloodless. But read between the lines and unease seeps through. Phrases like not fully understood or unexpected response to solar interaction appear again and again. Scientists pride themselves on explanation, but in Atlas's case, the explanations were either incomplete or conspicuously absent. Privately, the voices diverged. In interviews and conference hallways, some astronomers admitted astonishment. "I've never seen anything like it," one researcher confessed off-record. "We model comets for decades. We understand their fragility, and this thing just laughs at the sun. It's not supposed to work like that." Others leaned toward cautious wonder. "We may be seeing the first example of an interstellar body carrying materials outside our catalog. That's historic, no matter what it means." But alongside the astonishment came resistance. A different faction of scientists pushed back hard against the idea of treating Atlas as anything special. To them, every anomaly had a mundane explanation waiting to be uncovered. The green glow? Exotic ices. The trajectory shift? Outgassing masked by coma brightness. The anti-tail? Optical geometry. The survival of the CME strike? Coincidence, perhaps magnified by overestimation of the storm's impact. "There's no need to leap to conclusions," one astrophysicist wrote. "Every comet has quirks. This one just happens to have several at once." Yet even those downplaying the strangeness often betrayed discomfort in their tone. If everything was so easily explained, why did so many details remain open-ended? Why were models updated again and again only to fall short? Why, after weeks of observation, did the papers keep repeating the phrase, "further study required"? In the middle of the debate, certain names carried weight. Avi Loeb, who had already stirred controversy with his insistence that Oumuamua might be artificial, resurfaced in commentary about Atlas. He suggested the anomalies deserved serious consideration, that ruling out exotic explanations prematurely was unscientific. His critics rolled their eyes, accusing him of chasing publicity. Yet, his willingness to say aloud what others only whispered ensured that Atlas would not slip quietly into the category of just another comet. The conversation was forced into the open, uncomfortable as it was. Behind closed doors, some observatories debated how much to release publicly. There were concerns about fueling speculation, about feeding the endless online appetite for alien theories. One researcher admitted, "We don't want another Oumuamua situation. Every time we leave a gap, the public fills it with UFOs." Yet suppressing information only made it worse. By offering half explanations, institutions seemed evasive, which in turn fueled suspicion. Silence, paradoxically, became the loudest voice in the room. Among amateur astronomers, the reaction was very different. Free from institutional caution, they described what they saw plainly. A comet that grew brighter after being struck by a solar storm. A comet with tails that pointed in impossible directions. A comet that may have broken but still moved like a whole. Their images, though less precise than professional observatories, carried authenticity. Forums buzzed with debates not about whether it was unusual, but how unusual. In many ways, the amateurs spoke more directly than the professionals, their voices less bound by fear of ridicule. The division mirrored something deeper, a split between those who see anomalies as opportunities and those who see them as risks. For some, Atlas represented the thrill of discovery, proof that the universe still holds surprises even in familiar domains like comets. For others, it represented a threat, not of impact, but of credibility. To admit ignorance is one thing, to let the public run away with it is another. The guardians of mainstream science felt cornered, compelled to balance honesty with restraint. What made the voices even more complex was timing. Atlas's anomalies unfolded not in a vacuum, but in a year already filled with cosmic strangeness. Two novas flaring to naked-eye brightness, a solar cycle intensifying faster than predicted, Earth quaking and erupting in synchrony with auroras. Each event by itself might have been ignored. Together, they formed a drumbeat of the uncanny, and every time scientists dismissed one anomaly, another arrived to take its place. Their voices, already strained, began to sound defensive. The media played its part as well. Popular science outlets leaned into the drama, with headlines like "The Comet That Refused to Die" or "Interstellar Visitor Defies the Sun." Television segments showed glowing green streaks and whispered of mysteries. But mainstream news largely ignored the deeper scientific debates, preferring safe summaries that left the public in the dark about the real questions. For many viewers, the silence of experts looked less like caution and more like concealment. The voices that should have guided understanding seemed hesitant, fragmented, or muted. Even within the professional community, there were hints of rivalry. Some teams wanted to claim discoveries quickly, rushing papers that offered neat explanations. Others argued for patience, fearing that premature conclusions would only fuel distrust when they later proved wrong. The tension was palpable. Do we admit we don't know, one astronomer asked, or do we patch it with theories we don't fully believe? Neither choice felt safe, and hovering above it all was the ghost of Oumuamua. Its debate had scarred the field, leaving scientists wary of stepping outside conservative lines. Those who spoke boldly last time had faced ridicule or dismissal. Those who remained cautious were criticized for being unimaginative. Now, with Atlas, the same cycle began again. Voices split into camps: bold, cautious, dismissive, speculative. The echoes of that first visitor colored every word spoken about the second. What became clear is that Atlas was not just testing physics, it was testing the community itself. Could scientists admit anomalies without losing credibility? Could they speak honestly about uncertainty without being drowned by sensationalism? Could they hold the line between open inquiry and reckless speculation? The struggle played out in papers, press releases, interviews, and silence. The irony is that in the end, Atlas may not care about human voices at all. It glows, it fragments, it streams its anti-tale, indifferent to the debates it sparks. Yet the human response, the tension, the division, the whispered astonishment, is part of the story. For what we see in the sky is not just light and plasma. It is a mirror, reflecting our fears, our hopes, and our readiness or unpreparedness to face the unknown. The voices in the astronomical community remain unsettled. Some call it coincidence, some call it anomaly. A few cautiously call it unprecedented, and all of them know that Atlas will soon be gone, vanishing into the dark, leaving only questions and the echoes of their own divided voices. But as those voices waver, another thread in the tapestry emerges. For Atlas's defiance of the sun, its green glow and strange tales, may not be unprecedented after all. Ancient records and forgotten chronicles speak of visitors from the stars that behaved just as strangely, objects that glowed, survived, and carried the aura of something more than mere stone and ice. To understand Atlas fully, some argue, we may need to look backward as well as forward into the myths and memories of civilizations that saw these visitors before us. Historical echoes, the visitors in records. When modern astronomers look at Three-Eye Atlas and struggle to explain its defiance of the sun, they are not the first humans to be confronted with such mysteries. Long before telescopes and satellites, ancient civilizations gazed at the night sky and recorded visitors that defied ordinary explanation. Their language was not technical, but mythic. Their records are not data sheets, but epics, chronicles, and sacred texts. Yet when we sift through them, a strange resonance emerges. Again and again, we find accounts of luminous objects that seem to glow with unusual colors, survive near the sun, or behave in ways comets should not. For some, these are simply poetic exaggerations of natural events, but for others, they read like historical echoes of phenomena very much like Atlas. The Babylonians, meticulous in their sky-watching, left behind clay tablets filled with astronomical omens. Among their cuneiform inscriptions are references to stars that grew green in the heavens and torches that defied the sun. Scholars often interpret these as comets, noting that green is a color frequently associated with certain atmospheric or chemical reactions. But what strikes the modern reader is how explicitly these descriptions tie survival to meaning. A star that burns green and does not fade was not just an object, it was a sign, a portent of upheaval or change. The Babylonians saw in the sky what astronomers today debate in papers, a visitor that resists destruction, behaving as though it carried a will of its own. In China, centuries of imperial records preserved observations of broom stars, the ancient term for comets. Court astronomers recorded their colors, directions, and timings, often linking them with floods, earthquakes, or the rise and fall of dynasties. Among these chronicles are references to comets that shone both forward and backward, with tails pointing in contradictory directions. These double-tailed stars bear uncanny resemblance to what modern astronomers call anti-tails, rare features now witnessed in Atlas. The Chinese scribes did not speak of plasma dynamics or projection effects. They simply noted the impossibility, and rulers drew meaning from the strangeness. If a comet could point both toward and away from the sun, they reasoned, then perhaps the empire itself was being pulled in two directions. The Greco-Roman world preserved its own echoes. Pliny the Elder, in his Natural History, described comets that resist the fire of the heavens and glow with colors unnatural to stars. Medieval copies of his text added illustrations of green or flame-colored orbs with streaming banners. Historians often caution that Pliny's sources were second-hand and colored by superstition. Yet when an interstellar object like Atlas suddenly glows emerald after a solar strike, one cannot help but recall Pliny's astonishment at celestial objects that seemed immune to burning. To the ancients, such defiance was divine. To us, it is anomalous. The language changes, but the awe remains the same. Even in the Americas, oral traditions echo similar patterns. Mayan and Aztec codices speak of serpent stars that streaked across the heavens with bodies of jade light. Some accounts describe these stars as splitting, their fragments falling to Earth as omens of catastrophe. The connection to Atlas's suspected fragments and swarm-like behavior is haunting. A green star that divides and multiplies is not just a modern puzzle, it is an ancient fear, preserved in memory and myth. What unites these disparate records is timing. Again and again, unusual celestial events were linked to earthly unrest. Chinese chronicles tie comet apparitions to earthquakes and floods. Babylonian texts record stars burning strangely on the eve of wars. Roman accounts connect fiery visitors to political upheaval. Whether cause and effect or coincidence, the pattern is clear. Humans have long noticed the synchronicity between sky and earth. The recent clustering of solar storms, Atlas's survival, and seismic activity on Earth would not surprise an ancient scribe. They would nod knowingly and write it down as confirmation that the heavens and the world below move in lockstep. Skeptics, of course, argue that these historical echoes are nothing more than projection. Ancient peoples with limited understanding attached meaning to random cosmic events. Comets are common enough that some were bound to coincide with disasters. The green glow described in old texts might be cyanogen emissions or atmospheric distortion. Anti-tails, rare but known, could explain the double-tailed stars. There is truth to this skepticism. Not every poetic record is a literal account. Yet it is equally true that anomalies do occur, and ancient observers had sharp eyes. They may not have understood the mechanisms, but they knew when something was out of place. Consider this. Oumuamua, the first interstellar visitor, was dismissed by many as a rock until it accelerated without jets. Atlas, the third, has now survived a CME, glowed green without standard chemistry, and produced an anti-tail that defies casual explanation. If our modern instruments struggle with these anomalies, why dismiss the possibility that ancient witnesses saw similar things and simply described them in the only language they had? Their gods and omens may be our anomalies and data gaps, two sides of the same phenomenon separated by millennia. Some researchers take this further, exploring whether ancient myths of sky stones or heavenly shields could be rooted in repeated encounters with interstellar objects. If Atlas is not unique, if such visitors arrive more often than we realize, then human history may be punctuated by their appearances. The green star that resists fire, the serpent that points in two directions, the stone that splits and multiplies. These may not be metaphors, but memories. Our ancestors saw what we see, the defiance of cosmic visitors against the rules of ordinary comets. The implications are unsettling. If Atlas echoes not just Oumuamua, but records stretching back thousands of years, then we are not facing isolated mysteries. We are seeing a pattern, a recurring motif in the grand story of the skies. Interstellar objects that arrive briefly, behave strangely, and leave behind confusion may be a regular part of the cosmic cycle. And if that is true, then the ancients were not merely inventing myths. They were chronicling a reality we are only now beginning to rediscover. The historical echoes also serve as a warning. Ancient societies often viewed such visitors as harbingers of change. Their arrival was rarely seen as benign. Empires fell, plagues spread, earthquakes struck, all under skies marked by strange stars. Even if these links were coincidence, the cultural memory remains. To see a visitor that resists the sun, that glows green and multiplies, is to expect disruption. In our modern world, disruption may take different forms. Not emperors overthrown, but models overturned, certainties shattered, and physics rewritten. Atlas may not herald doom, but it forces us to confront the limits of what we know, which is its own kind of upheaval. Perhaps that is the true power of these echoes. They remind us that humanity has always been haunted by the sky, always humbled by visitors that defy rules. Whether carved into tablets, inked into codices, or captured on digital CCD sensors, the story is the same. Something comes from the stars, behaves in ways it should not, and vanishes before we can grasp it fully. We are left with fragments of data, of myth, of memory. 3 Atlas now joins that lineage. Like the green stars of Babylon, the double-tailed comets of China, and the serpent stones of Mesoamerica, it stands as a reminder that the universe is stranger than our categories. Its anomalies may one day be explained, but explanation does not erase the awe. The ancients understood that awe better than we sometimes admit. For them, it was the language of gods. For us, it is the language of anomalies. Different words, same wonder. And as we weigh these historical echoes, a more daring question emerges. If visitors like Atlas and Oumuamua appear regularly in human memory, if they carry resilience and strangeness across the ages, then perhaps they are not accidents at all. Perhaps survival under solar fire is not a fluke, but a feature, engineered or natural, to ensure that these travelers endure. The ancients may not have had the words, but they may have had the wisdom. The visitors are not just random stones, they are messages, written in green fire, repeated across centuries, waiting for us to finally understand. Yet before such speculation can be entertained, Atlas's story continues. If its resilience echoes the past, its resilience also challenges the present. For among modern voices, another possibility is whispered, one not of myth but of design. Could Three-Eye Atlas's behavior hint at engineered resilience, a construction rather than a coincidence? If so, the line between anomaly and intent becomes terrifyingly thin. Speculative theories, engineered resilience. There are moments in science when anomalies refuse to be smoothed over, when the standard explanations begin to fray, and what remains is a silence filled with possibility. Three-Eye Atlas, surviving a direct hit from a coronal mass ejection, belongs to such a category. The sun hurled a storm of magnetized plasma strong enough to cripple satellites and distort planetary magnetospheres, and yet this interstellar visitor emerged not shattered but brighter, its emerald glow intensifying, its form holding, its anomalies multiplying. For some, this is a puzzle of chemistry and plasma physics. For others, it is something more provocative, a suggestion that resilience of this scale might be accidental, but engineered. To even speak the word engineered in astronomy is to step into dangerous territory. Most scientists recoil at the implication, remembering the furor surrounding Oumuamua. In that case, a handful of respected voices dared to propose artificiality, suggesting that its acceleration without visible jets, its elongated shape, and its peculiar reflectivity could point to something constructed, perhaps a fragment of alien technology. The mainstream dismissed it as sensationalism, preferring natural explanations like hydrogen ice or nitrogen slivers, even when those theories strained plausibility. But the public never forgot. The idea lingered in headlines, books, and documentaries. And now with Atlas, the whispers return. The case for engineered resilience begins with the CME strike itself. Natural comets are fragile. They fracture under solar heat, disintegrate near perihelion, and shed material violently when stressed. Atlas should have died. Instead, it endured, and not only endured, but seemed to respond. The green glow intensified, the anti-tail appeared, and possible fragments clustered in suspiciously cohesive ways. These behaviors mimic not randomness, but adaptation. As if Atlas had a way of harnessing or redirecting the sun's energy, transforming chaos into survival. One theory imagines Atlas as a kind of probe, its outer shell resembling a comet, but concealing an interior built for resilience. To endure interstellar travel, such a craft would need shielding against radiation, impacts, and stellar winds. What better disguise than a comet's body, a structure we would dismiss as natural? When struck by the CME, its outer layers could have vented in controlled ways, redirecting plasma flow and preserving the core. The green glow in this view might be more than chemistry. It could be a byproduct of energy absorption, the object lighting up like a capacitor discharging after a surge. Another speculative angle focuses on magnetism. If Atlas carried a metallic core capable of generating or sustaining a magnetic field, it might deflect plasma much like Earth's magnetosphere shields us from solar storms. But what if that magnetic field was not accidental, but designed? An engineered traveler might deliberately exploit magnetic coupling to harvest energy or to maneuver. The trajectory anomalies reported after the CME strike could, in this theory, represent not damage, but guidance. An intentional adjustment in course using the storm itself as fuel. To human eyes, it looks like resilience. To more imaginative thinkers, it looks like control. Skeptics argue that invoking design is a lazy shortcut, a way to fill gaps with fantasy rather than patient data. They are right to caution against it. Yet speculative theories persist because the anomalies themselves persist. Every time one explanation closes a gap, another opens. The chemistry of the green glow does not match expectations. The persistence of the anti-tail resists projection models. The lack of dispersing debris contradicts fragmentation norms. At some point, the sheer accumulation of defiance forces even the most cautious to admit Atlas does not behave like the comets we know. If it is not behaving naturally, then what remains but to consider the possibility, however unsettling, that resilience is a feature, not a fluke. The notion of engineered resilience also fits a broader context. Interstellar travel, even for inert objects, is brutally hostile. Cosmic radiation, dust collisions, and stellar outbursts pose endless threats. A fragment of rock and ice would erode over millions of years. Yet both Oumuamua and Atlas appear oddly pristine, their anomalies suggesting durability. What if interstellar space is not filled with fragile debris, but with survivors, objects toughened or built to withstand the trials of the void? If so, then resilience is not just a quirk of Atlas. It is the hallmark of a population we are only beginning to glimpse. Cultural imagination seizes on this readily. Science fiction has long envisioned probes disguised as comets, ancient machines drifting among the stars, their true nature cloaked by ice and dust. Atlas, glowing defiantly under the sun's wrath, looks like the embodiment of that trope. The idea of engineered travelers also resonates with ancient myths, which describe sky stones that resisted fire, emerald stars that survived solar trials, and double-tailed visitors that chose their paths. Perhaps our ancestors saw resilience and interpreted it as divine will. Today, we see resilience and wonder if it is design. There is another layer, the possibility that engineered resilience does not mean technology as we define it, but biology, or something between the two. If panspermia is real, if life is spread across galaxies by comet-like couriers, then those couriers must be resilient by necessity. What if Atlas is part of such a system, not a machine, but a vessel of survival? Its glow could mark the release of organics, its fragments could be seeds. Engineered resilience, in this light, might not be the work of aliens in laboratories, but the slow evolutionary engineering of life itself, shaping travelers that can endure the fury of stars. Of course, speculation invites backlash. Many scientists argue that calling Atlas engineered is anthropocentric, projecting intent where none exists. They prefer natural explanations, however strained, over admitting design. And yet, one cannot deny that engineered resilience is an explanation, one that, unlike some natural hypotheses, accounts for survival, brightness anomalies, magnetic hints, and anti-tail phenomena in a single framework. Whether true or not, it unifies the puzzle in a way that piecemeal chemistry does not. The danger lies in overreach. Declaring Atlas artificial without proof risks credibility, but refusing to consider the possibility at all risks blindness. The wisest voices in the community strike a balance, acknowledging the strangeness, cataloging the anomalies, and admitting that if natural explanations fail, other frameworks must be explored. We should not rush to say it is engineered, one astronomer remarked, but we should also not rush to say it is not. That hesitation, that refusal to close the door, is itself a sign that Atlas has cracked the walls of conventional thought. For the public, engineered resilience is irresistible. It transforms an already extraordinary comet into a story of contact, intention, or purpose. Whether as probe, vessel, or seed, it captures imagination in ways icy body with unusual chemistry never could. And perhaps that is why official voices remain cautious, even evasive. They know that speculation spreads faster than data, and that once the idea of design takes root, it never disappears. Yet, even as debate rages, Atlas moves on. Its time in our skies is short, its mysteries compressed into a handful of weeks. But whether its resilience is natural or engineered, it has already left its mark. It survived where it should have died. It glowed where it should have faded. It split, or seemed to split, without dispersing. It streamed light sunward instead of trailing away. Each anomaly on its own is puzzling. Together, they create a portrait not of fragility, but of strength. Strength so great that many cannot help but wonder, was it built this way? In the end, the truth may slip away with Atlas itself. It will vanish back into interstellar dark, leaving only data, images, and the debates it inspired. But the question will remain, echoing long after. Was its resilience the accident of alien chemistry, or the intention of alien design? That distinction matters less, perhaps, than the realization it forces upon us, that we live in a universe where resilience is not guaranteed. And yet here it is, glowing green against the sun's wrath. And just as the possibility of engineered resilience unsettles, another chapter in Atlas's journey unfolds. For after surviving the sun, its path carries it onward, past Earth, past the inner planets, and toward a close encounter with Mars. If the CME altered its course or its fragments trail behind, then the red planet may soon bear witness to the next test. And this time, cameras are already watching, waiting to see whether resilience means more than survival, whether it means impact, transformation, or revelation on another world. The next observations, all eyes on Mars. For all the mysteries that 3i Atlas has already unveiled, its survival under the sun's fury, its emerald glow, its puzzling anti-tail, and the whispers of fragmentation, the story is far from over. In fact, many astronomers argue that the most decisive chapter lies just ahead. The interstellar traveler's orbit, even with its potential nudges and anomalies, is set to bring it closer to Mars than to any other planet. That proximity has transformed the red planet into the next proving ground. If Atlas still holds secrets, if its behavior is more than coincidence, Mars may be the stage where those secrets finally reveal themselves. For scientists, this is a rare and electrifying opportunity. Unlike Oumuamua, which zipped past Earth before anyone could gather much data, and Borisov, which behaved more like a normal comet despite its interstellar status, Atlas offers something different: a chance to watch an alien object interact with a planet under close surveillance. Mars is currently orbited by a fleet of spacecraft: NASA's Mars Reconnaissance Orbiter, MAVEN, ESA's Mars Express, India's MOM, and the newer Chinese Tianwen-1. Add to that rovers on the surface, still active and transmitting, and suddenly the scientific community has an unprecedented network of eyes already trained on the planet. If fragments pass near Mars, if dust clouds streak across its skies, or if Atlas itself brightens or shifts course, humanity will not miss it. The possibilities are tantalizing. If Atlas has indeed shed fragments during or after the solar storm, some of those fragments could intersect Mars's path. Even a pebble-sized piece hitting the Martian atmosphere would create a brilliant streak visible from orbit, while a larger impactor could stir up dust storms or carve new craters. The implications go beyond spectacle. An impact would allow scientists to study interstellar material directly. An analysis of ejecta or dust clouds could provide insights into chemistry forged in another star system. For decades, scientists have speculated about the role of interstellar comets in spreading organic compounds across galaxies. Atlas, striking Mars, could become the first real-world test of those ideas. But impacts are not the only scenario. Even a close flyby without collision may produce phenomena worth watching. Mars lacks a global magnetic field, leaving its atmosphere vulnerable to solar winds and passing bodies. If Atlas carries a magnetic field of its own, as some suspect, its encounter with Mars could produce strange auroral activity or disturbances in the ionosphere. MAVEN, designed to study atmospheric interactions, is perfectly positioned to detect such anomalies. A surge of energy, a flare of unexpected light, or an unexplained particle burst could provide indirect evidence that Atlas is far more than a frozen snowball. There is also the question of dust. Comets often clouds of particles that drift into planetary atmospheres, creating meteor showers. Mars has been on the receiving end of such events before. Most famously in 2014, when comet Siding Spring passed close enough to envelop the planet in a temporary haze of interstellar dust. NASA's orbiters recorded the event, noting chemical reactions and auroras unlike anything seen before. If Atlas sheds a similar dust storm, especially given its interstellar origin, the chemical fingerprints could reveal compounds unknown in our solar system. Imagine MAVEN's spectrometers registering molecules that do not fit terrestrial chemistry, or the rovers detecting organic residues after a light Martian snowfall of alien dust. The stakes are high because of timing. Atlas will not linger. Its hyperbolic orbit ensures it as a once-in-history visitor. If Mars provides even the slightest interaction, this may be humanity's only chance to study interstellar material up close before it slips back into the dark between stars. Every observatory, every spacecraft, every rover becomes part of a planetary-scale watchtower, ready to seize what may be a fleeting moment of revelation. The excitement is matched by unease. Some worry that a fragment striking Mars could unleash consequences we are not prepared to interpret. Mars is a fragile system, with a tenuous atmosphere easily disturbed. A large enough impact could trigger global dust storms, choking the skies for weeks or months. Such storms have crippled rovers before and could complicate future missions. Others whisper about stranger possibilities. If Atlas carries exotic chemistry, or worse, engineered resilience, what happens if fragments mix with Martian soil? Could they alter chemistry, seed reactions, or create effects mistaken for signs of life? For a planet already central to the search for life, an interstellar contamination could complicate interpretations for decades. Astronomers remain divided on the probabilities. Some insist that the odds of a direct impact are slim, that Atlas will pass at a safe distance, its fragments dispersing harmlessly. Others note that even a slim chance is enough to warrant intense observation. The truth is, no one knows exactly how Atlas will behave. Every anomaly it has displayed so far, survival, brightness, tail direction, trajectory shifts, has defied expectations. To assume Mars will be untouched is to assume Atlas will suddenly start behaving like an ordinary comet, something it has refused to do since discovery. Public imagination, as always, has run ahead of data. Online forums speculate about alien probes crashing into Mars, about interstellar seeds planting themselves in Martian dust, about coordinated arrivals of objects like Atlas as part of a cosmic plan. NASA and ESA tread carefully, releasing cautious statements that emphasize opportunity without indulging in speculation. Yet the very act of preparing every spacecraft to watch closely betrays the truth. They know something extraordinary could happen. Whether it is a flash in the atmosphere, a chemical signature in dust, or a glowing anomaly recorded by MAVEN, they are bracing for surprises. The comparison to Oumuamua lingers over all of this. That visitor slipped by with barely any warning, leaving behind a trail of questions we may never answer. Atlas is different. It has given us time. Time to prepare, to watch, to test. Mars, with its global network of machines, offers a vantage point Oumuamua never afforded. If anomalies emerge, this time we will catch them in detail. And if nothing unusual occurs, if Atlas passes uneventfully, it will still provide a critical baseline. The first interstellar body studied this closely by multiple spacecraft simultaneously. What makes this moment haunting is not just the science, but the symbolism. Mars has always been humanity's mirror, the planet of war, the planet of dreams, the planet we imagine as our next home. To see it confronted by a visitor from the stars is to witness myth and science colliding. Ancient cultures spoke of omens when comets drew near planets, reading destiny in their movements. Now we stand on the edge of our own myth, but armed with spectrometers and rovers instead of scrolls and prophecies. The question is whether our tools will pierce the mystery, or whether Atlas will leave us, like Oumuamua, with more questions than answers. All eyes are on Mars because the stakes reach beyond science. If Atlas interacts dramatically through impact, dust, or electromagnetic disturbance, it may offer the first tangible evidence of interstellar material altering another world in real time. That would be history-making, not just for astronomy, but for humanity's place in the cosmos. It would prove that the visitors we glimpse briefly can leave fingerprints, not just mysteries. And it would force us to reckon with the possibility that such fingerprints have shaped worlds before, perhaps even Earth itself. For now, telescopes track, spacecraft adjust instruments, and anticipation builds. Mars waits, silent under its thin sky as the green survivor approaches. Soon, the universe will show whether the interstellar traveler passes quietly, or whether its next act will be written in Martian dust and light. Either way, the red planet will become the stage for a spectacle that binds ancient myth to modern science. A world watched by humanity, a visitor watched by the sun, and a convergence that may reveal truths we are not yet ready to face. And even as all eyes turn to Mars, another layer of strangeness refuses to fade. For the timing of Atlas's survival, its anomalies and its path past Mars are not unfolding in isolation. They are part of a year already marked by celestial upheavals. Two novas blazing into naked eye visibility, auroras sweeping Earth, quakes and eruptions rising in synchrony. If Mars is the proving ground, then perhaps it is not just Atlas on trial, but our very ability to distinguish coincidence from pattern in a universe that seems increasingly unwilling to play by the rules. The bigger pattern emerging. By the time 3 Atlas survived its solar trial and turned its course toward Mars, one question lingered in every mind paying close attention. Could this really be coincidence? Was it just random chance that in a span of weeks the sun erupted with unusual fury, Earth trembled with earthquakes and volcanoes, auroras painted skies far from the poles, novas exploded into naked-eye brilliance, and an interstellar visitor not only endured but grew brighter in defiance? Skeptics repeat the mantra of randomness, but even they struggle under the weight of clustering. One anomaly can be dismissed, two can be tolerated, but when the anomalies arrive in chains, linked in timing, resonance, and an effect, the argument for coincidence begins to look less like science and more like denial. The pattern does not begin with Atlas alone. Oumuamua, the first interstellar object, left us unsettled with its acceleration without jets, its lack of coma, its elongated and tumbling form. Borisov followed, less dramatic but still bearing alien chemistry, confirming that interstellar bodies do reach us and may not match our models. Now Atlas has come, and instead of fading quietly, it has screamed anomalies. Magnetic hints, an anti-tail, a green glow without the expected compounds, and resilience under a solar storm. When the first three visitors from interstellar space each behave unlike anything we've seen before, what do we call it? Not coincidence, not chance, pattern. Layer this onto the solar cycle, which has surged faster and fiercer than predictions. The sun has flung more CMEs, more X-class flares, and more turbulence into the void than expected at this stage. It is as if our star is restless, awakening early, roaring into activity as if timed for maximum spectacle. Into this chaos wandered Atlas, almost as if summoned, perfectly aligned to take a direct hit from one of the most powerful storms of the year. It is the kind of timing that even seasoned scientists admit feels uncanny. What are the odds, they ask, that an interstellar traveler would be in the precise path of a CME at its peak, survive and emerge altered? The math resists easy calculation. The impression, though, is clear. Something larger is unfolding. Earth's own unrest only amplifies the sense. Seismic spikes, volcanic activity, atmospheric disturbances, none of these can be directly traced to the sun or to Atlas. Yet their timing presses against coincidence like fingers against glass. Ancient cultures would never have doubted the connection. They would have recorded it as cosmic cause and earthly effect, the heavens and the world below locked in dialogue. We moderns resist such thinking, clinging to separation, insisting that the ground does not heed the sky. But what if it does, in ways subtle and unmeasured? What if planetary systems resonate with solar rhythms, and solar rhythms are nudged by visitors from beyond? The pattern that emerges is not one of isolation, but of entanglement. Consider, too, the persistence of color. Atlas glows green, not with the expected cyanogen, but with something else, something not yet fully explained. Oumuamua's reflectivity baffled us, as did Borisov's gas ratios. Light is the common theme, objects from other stars bending or emitting light in ways that resist standard chemistry. Add to that the novas, stars detonating into visibility in the same cosmic window, and light becomes the motif of the year. Not just light, but unnatural light. Emerald comas, unexplained accelerations, twin novas, auroras invading temperate latitudes. The sky is filled with signals, all written in brightness. If the universe speaks in photons, then 2025 reads like a paragraph, one sentence after another, a larger message forming whether we are ready or not. The anti-tail adds another stroke to the picture. Comets point away from the sun, except when they do not. Atlas's sunward stream appeared just after its solar strike, glowing defiantly as if responding rather than obeying physics. Ancient Chinese records of double-tailed stars, Babylonian inscriptions of green torches resisting fire, all echo back now with startling relevance. It is as though history itself joins the chorus, reminding us that this is not the first time humans have seen anomalies that break the rules. What we call coincidence today, the ancients called omen. And while we dismiss their interpretations, we cannot deny the records exist. They saw what we see, patterns too strange to ignore. Scientists often warn of apophenia, the brain's tendency to see faces in clouds and patterns in noise. But what if the opposite danger exists as well? What if the greatest mistake is not seeing patterns where none exist, but refusing to see them where they do? Atlas has forced this uncomfortable question. Each anomaly, survival, glow, tail, trajectory, could perhaps be explained singly. But together, and in the timing of Earth's upheavals and the sun's fury, they begin to compose a pattern larger than the sum of their parts. A pattern of visitors arriving in sync with stellar tantrums. A pattern of anomalies clustering in ways that history, myth, and modern instruments all record. The pattern also extends into silence. Agencies release minimal statements, papers hedge their language, voices tremble with caution. Information that should be headline news, an interstellar object surviving a CME intact, is relegated to technical notes. The silence itself becomes part of the pattern, as if the institutions built to explain the universe are reluctant to admit how much they do not understand. The more anomalies cluster, the quieter the explanations become. The louder the questions grow, the less is said. Silence becomes its own anomaly, its own piece of the puzzle. What does the bigger pattern point to? Some argue natural cycles, solar peaks, geological rhythms, interstellar wanderers appearing in clusters by chance. Others see deeper connections, resonances between stars, planets, and cosmic debris. And still others whisper of intent, of visitors engineered to endure and timed to arrive, of patterns not random but written. Each interpretation reflects the lens of the observer. The scientist sees cycles, the mystic sees omens, the speculative thinker sees design. But beneath all interpretations lies one shared admission. What is happening is not ordinary. Mars now stands as the next test in the unfolding pattern. If Atlas interacts with the red planet, through dust, fragments, auroras, or impacts, it will add another link in the chain. Earth trembled when Atlas survived the sun. Mars may flare when Atlas passes. If both planets bear witness to anomalies in the same window, the pattern sharpens further. No longer coincidence, no longer apophenia, but something undeniable, a sequence that demands explanation. Perhaps this is the true meaning of Atlas, not as a solitary comet, but as a node in a tapestry. Oumuamua, Borisov, Atlas, 3 visitors in less than a decade, each bearing strangeness, each defying expectations. The sun roaring louder than predicted, Earth trembling, Mars waiting, history echoing, silence spreading. The pattern is not hidden, it is in plain sight, etched across sky and ground, star and planet, science and myth. It is not a single mystery, but a web of mysteries, converging into something larger. What that larger something is remains uncertain. Perhaps it is the dawn of a new understanding of interstellar bodies. Perhaps it is evidence of deeper physics at play, forces linking stars and worlds in ways we barely sense. Perhaps it is even a demonstration, a performance staged across cosmic scales, reminding us that we are not the sole audience in the universe. Whatever it is, the bigger pattern cannot be ignored. Atlas has ensured that. Its green glow, its survival, its defiance, they are not isolated anomalies, but brushstrokes in a painting too vast to see all at once. And so, the question lingers, are we witnessing coincidence, or are we standing at the threshold of revelation? The bigger pattern suggests the latter. The universe is not just whispering, it is speaking in storms, in lights, in tremors, and in visitors from the stars. Whether we listen or whether we dismiss is up to us. But one truth grows harder to deny. The pattern is real and it is growing. Yet even as we begin to grasp the shape of this pattern, another enigma rises from the silence. Why, in the age of satellites and probes, does data about Atlas arrive in fragments and delays? Why do public numbers lag behind whispered reports from observatories? If the pattern is larger than coincidence, could part of it lie not in what we see, but in what is withheld?